You've heard of Yellowstone, but what if I told you there's another supervolcano hidden beneath a bustling European city, far more active and potentially more dangerous? Forget what you think you know about global geological threats, because Italy holds a secret that could dwarf any eruption in modern history. This is Campi Flegrei, and its awakening could change the world as we know it. While Yellowstone's massive caldera captures headlines with its potential for cataclysmic eruptions, Campi Flegrei, nestled under Naples, Italy, poses a more immediate and complex threat. This article dives into the geological realities of this lesser-known supervolcano, its potential global impact, and why it demands our attention now. Yellowstone National Park's supervolcano is often the poster child for apocalyptic volcanic scenarios, with its massive caldera capable of ejecting over 240 cubic miles of material, earning it the supervolcano label, VEI-8. But Campi Flegrei, or the Phlegreian Fields, is a different beast. Unlike Yellowstone, which last erupted 640,000 years ago, Campi Flegrei has a more recent and active history, with its last eruption in 1538 forming the Monte Nuovo cinder cone. Its proximity to a densely populated urban area, home to over 3 million people in the Naples metropolitan region, makes it a ticking time bomb. While Yellowstone's remoteness limits immediate human impact, Campi Flegrei's location under a major city amplifies its threat. Geologists argue that its frequent seismic activity and ground deformation signal a restless system, potentially closer to eruption than Yellowstone's dormant giant. Campi Flegrei is no stranger to unrest. Since the 1950s, the region has experienced episodes of bradyseism, slow ground uplift or subsidence caused by pressure changes in underground magma or hydrothermal systems. Between 1982 and 1984, the ground rose 1.8 meters, triggering over 1,300 earthquakes per month and forcing the evacuation of 30,000 people in Pozzuoli, a town at the caldera's heart. Since 2004, uplift has resumed, with rates reaching 2 cm per month by May 2024, and seismic swarms have intensified. In 2024 alone, 6,240 earthquakes rattled the region, including a magnitude 4.4 event on May 20th, the strongest in 40 years. These swarms, often centered around Pozzuoli, indicate stress release as the crust stretches and fractures, potentially paving the way for magma or gas to rise. Unlike Yellowstone, where seismic activity is less frequent, Campi Flegrei's constant rumbling keeps scientists and residents on edge. Picture a sprawling, 13-kilometer-wide volcanic caldera, invisible to the untrained eye, blending seamlessly into the vibrant landscape of Naples. Campi Flegrei isn't a single towering cone like Vesuvius, but a complex network of 24 craters, hydrothermal vents, and fumaroles, many hidden beneath urban sprawl or the Gulf of Pozzuoli. The Solfatara crater, a tourist hotspot until its closure in 2017, emits sulfurous fumes and boiling mud, a stark reminder of the heat below. Ancient Roman ruins like the submerged city of Baiae testify to centuries of bradyseism, with ground movements leaving structures underwater. Pozzuoli's marina, now a mudflat due to uplift, and the fertile Campanian plain, enriched by volcanic ash, highlight the region's dual nature, a place of beauty and danger. This caldera, part of the Campanian volcanic arc alongside Vesuvius, is a geological marvel and a potential catastrophe waiting to unfold. Campi Flegrei's eruptive history is staggering. Its largest known event, the Campanian Ignimbrite eruption around 39,280 years ago, ejected 265 cubic kilometers of material, VI-7, blanketing Eastern Europe with ash and possibly contributing to a volcanic winter. Another major eruption 15,000 years ago, the Neapolitan Yellow Tuff, produced 40 cubic kilometers of material, forming the caldera's current structure. The recently identified Maddaloni X6 eruption, 109,000 years ago, was nearly as large, suggesting a pattern of massive recurring outbursts. Two competing models explain Campi Flegrei's current activity: the shallow magma model, and the hot fluids model. The shallow magma model suggests magma is pushing upward, causing ground uplift and seismicity, potentially leading to an explosive eruption. In contrast, the hot fluids model attributes unrest to steam and gases from deeper magma, which could result in a less destructive phreatic eruption, where hot liquids, gases, and rock fragments are ejected without lava. Recent studies favor the hot fluids model, citing high carbon dioxide emissions, 4,000–5,000 tons per day, and the shape of the ground bulge, centered in Pozzuoli. A 2025 study revealed a geothermal reservoir, capped by a self-healing tuff layer 4 kilometer deep, traps gases, causing pressure buildup and earthquakes. This reservoir, not magma, may drive the unrest, offering hope that managing water flow could mitigate risks. Predicting eruptions at Campi Flegrei is like diagnosing a patient without seeing inside. The Vesuvius Observatory, operated by Italy's National Institute of Geophysics and Volcanology, INGV, monitors seismic activity, ground deformation, and gas emissions using drones, seismographs, and thermal sensors. Despite advanced technology, the subsurface remains opaque. A 2023 study predicted that an additional 30–40 centimeters of uplift could lead to crustal rupture, a precursor to eruption, and recent data confirm this trend. However, distinguishing between magma-driven and hydrothermal activity is tricky, and political pressures complicate raising alarm levels. Unlike Yellowstone, where sparse population allows for longer response times, Campi Flegrei's urban setting demands rapid, accurate forecasts to protect millions. An eruption, even a small one like 1538, would be catastrophic for Naples. A phreatic eruption could spew toxic gases and ash, disrupting air travel and infrastructure. A VI7 event, though rare, could render the Apennine Peninsula uninhabitable for decades, with ash clouds affecting Europe's climate and agriculture. The 1982–1984 unrest, which displaced 40,000 people, hints at the chaos a larger event could unleash. With 500,000 residents in the red zone and 1.3 million in high-risk areas, evacuation plans face logistical nightmares. Hospitals, prisons, and densely packed towns like Pozzuoli would struggle to relocate, and panic could exacerbate the crisis. Campi Flegrei's past eruptions offer clues to its global impact. The Campanian Ignimbrite eruption 40,000 years ago may have accelerated Neanderthal extinction and triggered a volcanic winter. A modern equivalent could disrupt global air travel, agriculture, and economies, with ash clouds blocking sunlight and lowering temperatures. While Yellowstone's eruptions would primarily affect North America, Campi Flegrei's proximity to Europe's economic and cultural hubs amplifies its threat. The 2023 study in Geology and 2025 study in Science Advances suggest that managing the geothermal reservoir could reduce risks, but a large eruption remains a wild card with worldwide consequences. Italian authorities have raised Campi Flegrei's alert level to yellow, signaling the need for monitoring. Evacuation plans assume a 72-hour warning, but recent seismic swarms have prompted calls to update these to account for post-eruption evacuations. Proposals to manage water runoff and lower groundwater levels could reduce pressure in the geothermal reservoir, potentially preventing unrest. However, urban development, driven by the region's beauty and fertile land, has complicated mitigation. Relocating 500,000 people is daunting, and political inaction has delayed proactive measures. Unlike Yellowstone, where mitigation focuses on monitoring, Campi Flegrei requires urgent, actionable strategies to protect its dense population. Campi Flegrei is a geological enigma, a supervolcano hidden in plain sight beneath Naples, far more active and immediate than Yellowstone. Its history of massive eruptions, coupled with ongoing unrest, demands global attention. While Yellowstone's threat looms large but distant, Campi Flegrei's proximity to millions and its restless behavior make it a pressing concern. Advances in monitoring and new insights into its geothermal dynamics offer hope for managing its risks, but the stakes are high. As scientists refine their understanding and authorities grapple with preparedness, Campi Flegrei reminds us that the Earth's most dangerous threats often lie beneath our feet, waiting to reshape our world.